subtract and simplify if possible. We have here the difference of two rational expressions. To subtract them, I need to have a common denominator, which here I don't have a common denominator, right? In order to subtract two fractions, say a over b and c over d, the only way I can do this subtraction is if b and d are equal. So maybe instead of d, I have c over b. When I have that, I can do it with the a minus c in the numerator, put it over that common denominator. So I need to get a common denominator before I can do this subtraction, right? Our tool, of course, to get a common denominator is the same tool that we used with numbers, right? If I had something like 5/7 and I wanted to subtract from that 2/3, in order to do that, what we did was we went ahead and said, instead of a 7 and a 3, let's use their product, right? 7 times 3 and 3 times 7. Of course, to multiply by a 3 in the denominator, we had to multiply by a 3 in the numerator. To multiply by a 7 in the denominator, we had to multiply by a 7 in the numerator, so that all together, 3 over 3, that's 1. 7 over 7, that's 1. I'm multiplying 5/7 by 1 and 2/3 by 1. I'm not changing them. I'm just changing the way they're written. When we do that, we have a 15 minus a 14, so a 1. So we could write this subtraction as 1/21. 3 times 7 is 21, right? So that's how we did it with numbers. We went ahead and found a common denominator, which in the case of two primes was just, multiply one by the other and the other by one. If these were composite numbers, to get a least common denominator, we do something a little bit different, right? If this was instead of a 7, if this was a 14, say a 7 times 2, and if instead of a 3, this was a 6, which is a 3 times 2, right? We'd already have a 2 that's in common here and here. So to get this times something to equal this times something, we just got to multiply by the missing pieces. We'll multiply by the 7 here and the 3 there. All right, so we're going to see what pieces, what factors we have here, what pieces, what factors we have here, and we're going to find any pieces that are in here but not in there and multiply them in. We're going to find any pieces that are in here but not in there and multiply them in. So to do that, we need a factor. So let's go ahead and rewrite this, and I will write it in factored form. A squared minus 9, difference of squares, that's a plus 3 times a minus 3. Minus, I'm going to give myself a little room, minus 5 over a squared minus a minus 6. I know that that factors as an a minus 3 and an a plus 2, because negative 3 plus 2 is negative 6. Negative 3a plus 2a is negative a times a is a squared. Right. So here is the factored form, parenthesis, factored form of these two things. Looking at them, I see that there's an a plus 3 over here, but no a plus 3 over here. So let's go ahead and multiply in an a plus 3. Right? To do that, I got to multiply an a plus 3 in the numerator as well as the denominator, so that I'm multiplying by something divided by itself, by 1. All right, there's an a minus 3 here. There's already an a minus 3 there, so I don't need to multiply in another a minus 3. What about over here? Well, I know that a minus 3 and a plus 3 appeared over there already. The a plus 2 is here, though, and not there, so I'd like to multiply in an a plus 2. So we do that. Of course, to do that, I got to also multiply by a plus 2 in the numerator. All right, so now we have a common denominator. This common denominator is a plus 2 times a minus 3 times a plus 3, right? That appears in both our denominators. So we have a plus 2, we have a plus 3, and we have a minus 3. What do we got in the numerators? 6 times a, 6a. 6 times 2, 12. Minus, be careful with that minus sign, 5 times a, 5a. 5 times 3, 15. Right? Minus a 15. So let's go ahead and combine some terms. I got a 6a minus a 5a. That gives me an a. I got a 12 minus 15. That's a negative 3. A minus 3, that's one of our factors that shows up in the denominator. We're going to be able to cancel that, right? So I'll cancel my a minus 3's from the numerator and from the denominator, and that leaves us with a 1 in the numerator, and in the denominator we have an a plus 2 times a plus 3. And that's our final answer.